staff box at the end, so you can turn it and get yourself one release. Yeah. Works the carriage and weighing ground frame Dom wanted to pull, and when you get to Yarwell, the run round has got that as well. Yeah. Now, it was a big posh triangular lump of wood till it broke, and that's a Dave Holden special, but it's quite popular. This little beast does here, from the staff box up here down to Autumnmere. Then that dangly bit takes you through to Peterborough, working Peterborough ground frame. That's got the key on it for Overton ground frame. And that's our infamous bit of copper pipe which takes us Autumnmere down to Fletton Junction.
Here we are at Wansford and looking at this fantastic standard Great Northern lattice bracket from ex-French Drove on the former Great Northern / Great Eastern route, closed in 1982. The signal was an entrance to a loop at French Drove and did have a miniature arm on the left hand side. Now the Nene Valley Railway managed to acquire several signals from the route, and this was one of them, and it was re-erected virtually straight away at Wansford, as was. The miniature arm was replaced with the main arm, and the shunt was added, which you're looking at now. And after a few years of use, the wood boards at the top needed replacing, plus some of the bit of the metal work on it. So the Nene Valley Railway put an outside contract in for scope of redoing the metal work and some of the woodwork. And Collis was asked for a quote. Eventually, a grant was applied for, and Collis got the work for it. And as you can see, it's got a new GRP plastic walkway there at the top, underneath 24 and 23, and some of the metalwork's been repaired, and it does look quite fantastic. New metal handrails around there, footboards and midsection boards there. So it looks quite nice actually. Good deal of work's been done into that. Lasts a few more decades. Standard GRP plastic with all galvanised fittings and stainless steel fittings. This is stainless steel. Here we are down at the level crossing, and we're looking here at the gate heel drive cranks. Now, as you can appreciate, these are about 3 foot to 4 foot in scale, with the strengthening arm between them, and their purpose is to take the small movement from the gate wheel and give greater torque to the operation of the level crossing itself, just in front of us. They also drive the rising and falling stops. I'll also show you in a second. Now we're just outside the signal box here, and what we're looking at is some more of the gate drive equipment and the gate stop equipment. One of the things I love about Heritage Railways is our make, do and mend approach, and we have to make a lot of things to suit, to fit, because they don't exist anymore, and this crank is an example. It's got an extension piece here bolted through on a standard gate crank, and then welded up to what looks like 2 halves of a normal cow's horn to do the job, and it works quite well. These old Great Western style and Eastern Region style cranks, is this a GER? No, it's an LNER crank, this one. It's just stamped on the top LNER. Underneath there, you take that off, there's an oil pot for people nowadays will be more familiar with the standard type of cranks there with the grease nipples on, which you can access, but these are the older type. You can do the dash pot, put some oil in. This is a fantastic lead-off timber here just outside the front of Wansford box. The actual gates themselves are driven directly off the crank at the bottom here, off the main gate drive, on this fantastically large 2-inch square post, which is connected to the gates. The gates are clamped onto this, and then that drives round. Now I mentioned the rising and falling gate stops. That's what these are here, set in the road. There's another set just here as well, and another set just over there. Now the rising and falling gate stops, their purpose, as you can see, this side is chamfered, so as the gates come across, they drop down, gates pop over onto them, and end up trapped behind them. Then when the gate stops are pulled, these rise up in the air and trap the gates. Behind is another part that is the stop itself, stops them going any further than that. Now the ones in the road, as you can appreciate, they have to rise and fall. Obviously you don't want obstructions in the way of cars and vehicles and such. So what they have is the gate stops that rise, and also the front stops rise as well. So these are fixed in here, as you can see, you've got maintenance grids so they can get into them quite easily. And the 4 gates are driven directly off the ship's wheel in the signal box. This is one other crank I'd like you to have a look at here, just over the crossing there at Wansford Station. This is a scale beam crank. As you can appreciate, it's adjustable. You can just see there that you can actually slip it backwards and forwards on either side there. So it's effectively got 3 slippers when you think about it. There's one actually under the platform there as well. Now Keith has been very kind to give us these pictures taken while Collis was doing the rebuilding work upon the signal itself, and show some of the work that was undertaken. Now, for those who've never seen an eco point, or Z-lock as some of us call them, this is one in the flesh here at the Nene Valley Railway at Wansford Station, and this one is out of use at the moment, clipped and scotched up. But what happens is that this main drive shaft, a bit like an EP point machine on a Westinghouse machine, you pull the main drive shaft there, and the main drive shaft has this Z-shaped kicker in the middle of it. And the first thing that happens is, as you can see there is a bit of lost motion where it will unlock. Having unlocked, it will then kick the point across through this angled part of the mechanism. Finally, once it's gone over the other way, the last part is to relock in this piece of the mechanism there. Big and heavy, as you can appreciate. A few subtle differences. The front stretcher rod is raised up as opposed to a traditional stretcher rod on there, and generally doesn't go out of play if you keep the points in check. You do have detectors off these, which is what this piece of disconnected mechanism here is for. Can't show you that, it's disconnected, but that's for kicking the detector over to show the FPL is in, and you can still have your standard open switch and close switch rods off to your mechanical or electrical detector at the side. There is a locking piece again, which I don't know if I can actually show you. No, I'll have to show you this way. As you can see here, the locking piece is engaged in this side of the rod here, and when the points go over the other way, The other locking piece will engage in the other side there once it's over the other way. One of the nice old piece of equipment here that you can still find on a lot of heritage railways, mostly replaced by track circuiting, and this is before the days of track circuiting. What you have here is a fouling bar, extends down to just before the drive rod there. You can see going into the facing point lock, traditional facing point lock. This one is about 25-30 foot. You can get them up to 50 foot. They used to be even larger at one time, but over years they've been reduced in size due to incidences. But basically what happens is the drive rod for the FPL comes in through this spring return mechanism, and at this point it kicks a lifting eye on the fouling bar, and its mechanism will be to lift the bar upwards as such. That bar lifts along its whole length until it gets down to the other end. It will drop on that end. This is the opposite of the opposite end. This end was a lift, this end is a drop, and as it drops it will then push the end. If there's a train anywhere on this piece of approach track, as the bar tries to lift, the flange of the wheel of the rail and the train will prevent that from lifting and prevent you from locking the facing point lock. So it does the same job as a track circuit. It's a forerunner to track circuits. Track circuiting obviously more advantageous, you go further out, etc. But this was the forerunner to track circuiting, and that's exactly what it does. It prevents you putting the facing point lock in if there's a train on the track, on the approach track. The return spring helps take that weight down, because as you can appreciate there's a lot of metal work there attached to the rail.